Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam NIOS syllabus. So science topic called motion and its description. We already seen some of the important items as far as motion is concerned. The first one is what is called as motion. So when a body moves from one position to another, then we say the body is in motion. Is it not? So it changes its position. And also you have seen different kinds of motions as rectilinear motion, motion along a straight line. Suppose keep a ball on a table and make it to move. It moves in a line. Is it not? So any motion in a straight line is called as rectilinear motion. Light also travels in straight lines. The circular motion, we discussed about the what is called as a beautiful merry-go-round. It is circular motion. Similarly, movement of planets, almost circular. Even some of the electrons around the protons and neutrons or nucleus, around the nucleus, they move in almost circular motion. And you have already seen about oscillatory motion, the motion of the pendulum of a clock, or a simple pendulum also moves in a oscillatory motion. Is it not? There will be one fixed position, moment of rest, then it moves to the one side, that is called swing, and it go to other side. So that is called as oscillatory motion. Also you have heard about swinging, wherein the children will sit on a platform, a plank connected with a rope and made to move from one side to another. That is called oscillatory motion. And also we have heard about erratic motions like that of hurricane, then you have tsunami, etc. That is called erratic motion. Of course, it cannot be measured, but all these can be measured. And also we have seen about distance and distance traveled by and displacement. Distance means total distance covered by a body. Displacement means shortest distance. Suppose you have a body in the form of a body moves from one point, say point A, a body moves from here, comes to a point called B. We say a body moves in the which direction? This is eastern direction. Okay, and then it moves to north to a place called C. And suppose this distance is say 3 kilometers and this is 4 kilometers. Distance travelled will be equal to 3 plus 4, that is 7. We call it as AB plus BC. So distance will be 3 plus 4, that is 7 kilometers. If it is kilometer or meter also you can take. Displacement means shortest distance from A to C. Because this is right angle triangle, this is called as hypotenuse, longest side. So we have displacement is equal to AC square is equal to AB square plus BC square. AB how much? Let us take 3. BC how much? 4. So 3 square is 9, 4 square is 16. That comes to 25. So AC becomes root of 25. That is equal to 5. So displacement becomes 5 kilometers. It is the shortest distance. Even you will also have experience of all this. Between two places, there will be long route, there will be one wrong route. That is called distance traveled. And you will find out some short route. That is what is called as displacement. We always prefer short routes, is it not? As already we have studied. Also we have studied about speed and velocity. Rate of change of distance is called as speed. S is equal to d by t, distance by time. It is measured by the unit meter per second. So velocity is rate of change of displacement. Formula is same, but here d means displacement. What is the difference? What is the difference between the two? Displacement is the shortest distance. It is a vector quantity. So both are measured by meter per second only. But difference, if we say, speed is a scalar quantity, whereas velocity is a vector quantity. What do you mean vector quantity? Vector means which has a direction. Speed means no direction. So birds fly in the sky, right? They have no direction. Sometimes they move up, sometimes they come down. Have you seen it? No direction. This is what is called speed, we say. Even the wind also blows. And when it blows, that will be speed of it. Vector means, suppose aeroplane moves from Bangalore to Chennai, or Bangalore to Mangalore, or Bangalore to Mumbai. So it has got fixed direction. That is what is called as velocity. So in our ordinary language, both are same, but scientifically, velocity and speed are different. And also we have seen about average speed and average velocity. So total average speed means what? Total distance covered by total time taken. Total time taken, that will be equal to average velocity, average speed. Average velocity means total displacement by total time taken. That is what is called as total time taken for a particular journey. That is what is called as average velocity. Is it not? And that will be referred to the movement of a train or a bus or a car, etc. We use these words. Is it not? That's all we have seen in the previous lessons. Now when coming to home assignments, I think some of you have already done it, right? A cyclist moves along the path shown in the diagram. Takes 20 minutes from point A to point B. So from here to here it takes about 20 minutes. 1 minute means how many seconds? 20 into 60, so much of seconds, right? always you must write in terms of MKS units. What is MKS? Meter, kilogram, seconds. Find the distance, displacement and speed of the cyclist. Three things you must find out. Find the distance. Distance means first from A to C he moves. From C he will come to B. So that is 80 plus 60 becomes 140. So total distance becomes 140 kilometers, 140 meters. Coming displacement, it is a vector quantity by using Pythagoras theorem. What is Pythagoras theorem? We already studied in the previous classes. This refers to right angle triangle. In right angle triangle, the square and the hypotenuse means AB square is equal to sum of the squares of the other two sides. What are the other two sides? AC and BC. So AC square plus BC square. So 80 square plus 60 square, that comes to 6400 plus 3600. Add it becomes 10,000. So square root of that is 100. Speed of the cyclist is equal to distance by time. Distance is 140. Time is 220 into 60. Why 60? 1 minute is equal to 60 seconds. Okay, that's why. So 140 by 1200, then 0 cancels. Your 2 7s are 2 60s are 7 by 60 meter per second. Is it alright? Is a 2 marks question. Be ready for such questions in the exams. One more question. A train has to cover a distance of 1200 kilometers in 16 hours. So 1200 kilometers is distance, time is 16 hours. So you have 800 by 10. Now this speed will be equal to 1200 by 16. That will be the speed. First 800 kilometers covered by the train in 10 hours. So this is 800, 10 hours. So distance by time, that will be speed for first 10 hours. And what should be the speed of the train to cover the rest of the distance? So speed of the train to cover remaining distance, that is 400 kilometers, because 800 is already covered in 10 hours. And 400 by x we will take. Time we don't know. They are asking that only. Okay. So 400 by x is equal to 10. So this is x means, so distance is 400 and time is 10 hours. So that will be equal to, time is 6 hours. So 400 by x is equal to 10. And when you compare, so this is not 10 actually, 10 is already covered, this will be 6. So 400 by x is equal to 6. So you have 6 into x is 6x is equal to 400. X is equal to 400 by 6, 66.67 kilometers. Is it alright? So what happens? First it covers 800 kilometers. Then how much remains? 400 remains. So 400 by, the speed is not known. So you have distance by, this should be speed, not time. So distance is 400 by speed x is equal to 6 hours. So that is how you got it. 6x is equal to 400, x is equal to 66.67. That is the answer for the first question. What should be the speed of the train? So speed of the train for the remaining distance. Speed of the train for the remaining distance is equal to 66.67. First 800, it is 80 kilometers. Next 400, 66.67 kilometers. Is it alright? So note this change. This is not time. This should be speed. Okay. And also this should be 6 hours because ton is already covered. Totally 16. So that should be 6 hours. So please make that change. Okay. Now coming to the next part. Average distance. Average means what? First it was 80 kilometers. Now it is 66.66. So this is for the first 10 hours. And this is for the next 6 hours. This is the speed. So average of that too. That will be 80 plus 66.66. That is 146.66. It continues like that. So if you divide it, it will be 73.33 kilometer per hour. Okay. That is the average speed of the train. So that is that question. And for today's topic, we have graphical representation of motion. Second is some problems, numerical problems. Third is acceleration. And also you have retardation. Okay. So first graph is called position time graph. What do you mean by graph? Graph is a representation of the data by means of lines or curves sometimes. And what does it do? It shows, or it is easy to analyze and understand the motion of the object if it is represented graphically. You may ask where these graphs are used. Your exam results, for example, in some of the schools they display. In SLC examination, so many students have appeared every year. Say starting from 2010. If the school started in 2010, 10, 11, 12, 13, 14 like that up to 2020, the results are put with the columns. And by seeing the columns, what is called as bar graph, we can make out which year the result was very good, which year result was not so good, like that. We can compare, no? See here also, to draw a graph of the motion of an object, its position at different times are shown on y-axis, time on x-axis. So time is taken on x-axis. So every graph will have two axes. One is called as x-axis, another is called as y-axis. So this is called position time graph. Here, this is the data. This is the position of the body. That is told in terms of meters. And this is the time. Time is told in terms of seconds. This is in meters. So this axis is called as x-axis. The line which is horizontal is called as x-axis. The line which is vertical is called as y-axis. To draw this graph, we want what is called a scale. Not your scale which you are drawing for line. Here scale means, see the distance like meters etc. cannot be shown in the book or paper or a board, right? We must make it, reduce it in a small thing. For example, if you want to draw India map, you cannot draw India in your book. Your book is so small. How can I bring the whole India there? Or Karnataka map? Or if you want to draw a shape of a human being, you cannot bring the size 6 feet, 4 feet like that. What you will do? Take a small scale, what do you call? Here also scale is taken. What is that scale? 1 second is equal to 1 centimeter. So these are in seconds. That is how it is done in the x-axis. In y-axis, 10 meter is equal to 1 centimeter, like that. So that is a scale taken. And this is the data given. Means this is the time in seconds starting from 0. What is that point 0 called? The 0 is called origin. Where all the data started, no, this is called as origin. From the origin O, we have x-axis and y-axis. Is it not? So this point is called origin. And this is the data. What is the data? The distance travelled by object at the end of 1 second is 10 meters, 2 seconds 20, 3 seconds 30 meters, like that. So this is the given data, and if it is represented graphically, that will be nice. So that is what I just now telling you. So figure 9.20 shows the graph. So one division of horizontal axis represent 1 second of time, and one division of vertical axis represent 10 meters. Okay. So what you are going to get? We are going to get a straight line, and that straight line making an angle of 45 degrees. Is it not? That is how a graph is drawn. So this is the data and this is the graph. Here this is the graph of position versus time. Position on the y-axis, time on the x-axis. And for a 1 second 10 meters, 2 seconds 20 meters, 3 seconds 30 meters, like that is joined. You get a slope line, which is a straight line. So this is one kind of graph that is being used in this chapter on distance. Second one is velocity time graph. What is velocity? Velocity is defined as rate of change of displacement. So velocity formula, V is equal to d by t, where d stands for displacement. It is a vector quantity. Why I am repeating? Just to make it thorough in your minds. Should not forget, okay? So here velocity time graph, take time on the horizontal axis called as x-axis, velocity on the vertical axis on a graph paper. Let one division on horizontal axis represent 1 second as in the previous case, and one division on the y-axis represent 10 meter per second. So this is the data given. Here velocity of A and velocity of B are compared. Suppose you have two trains starting from the same point, or suppose you have two buses or two cars or two vehicles, whatever it is, and these are the velocities of their movement, and against a time. That has to be displayed in the form of a graph. So here this graph what you are getting, so this is the graph. This is for the object A, this is for the object B. In the case of object B, it will be a parallel line. Here this is a velocity in terms of meter per second, y-axis. In the x-axis you have time. For every 1 centimeter means 1 second. So this line that is drawn parallel to this, that comes to parallel, that's how you mark it. 1 second here, 2 second here, 10, 10, 10, all 10 only it comes. That is for a straight line. It is a parallel line. What do you mean parallel line? A line which is equidistant at all places from a given line. So the distance is same. Where can you see it? I think all of you have seen the train track. The distance between the two railings will be same. Suppose it is a meter gauge, it will be 1 meter. Broad gauge, little more. Is it not? So distance is same throughout. That is called parallel lines. So this is in the case of a object B. This is the case of a object A. So once again we will see QR and PQ represent the motion of the object A and B. And how you got it? That is just because of the data. This is of A, data of A, this is data of B. Here you see all 10, 10 only comes. So movement of B is uniform. That's why only 10 comes. That's how you get a parallel line. Whereas velocity of A go on increasing steadily. Is it not? So that is the explanation of that, how it is drawn. So velocity is constant in the case of B. In the case of A, you have a line, it comes, and that will be making an angle of 45 degrees. So formula will be formula V. So distance displacement of an object in time t with uniform velocity v, x is equal to vt. Just now we told v is equal to x by t. So other way of telling this is x is equal to vt. What is v? V is velocity. What is t? T is time. Product of these two is called displacement in case of velocity, distance traveled in case of speed. Okay. So this is the graph. I think you have understood how to do it. All of you practice it. Okay. So there are two graphs here. One is called PR. This is called PQ. PQ is parallel to O, horizontal axis, and this is inclined at an angle of 45 degrees. Okay. Now comes a new topic called as acceleration. Rate of change of velocity of a body is called as acceleration. Formula: change in velocity by time taken, measured by the unit called meter per second square. Formula is: suppose a body starts with the initial velocity u. So initial velocity of a body. What do you mean initial velocity? The velocity of starting velocity is called u. What is the unit of that? Meter per second. And let us suppose the final velocity of the body is equal to v meter per second. Of course, we are going to derive it afterwards. And the time taken is, let us suppose, t seconds. So what is the change in velocity? Change in velocity is v minus u. For example, a bus or a train starts from rest, then u becomes 0. After some time it picks up speed. So you have a is equal to v minus u, the time is t. So change in velocity is v minus u, time is t. This is what is called as acceleration. You may ask a very simple example. Most of you have gone in train, right? And in railway station, there will be a train starting point. A train will be waiting there, and there you have a fixed time. Suppose the time is 10 o'clock. Up to 10 o'clock it will be standing there, is it not? And there will be a bell at 9:50 or so. They give one bell, long bell, something like a whistle also they put, and that is a caution that the train will start now in a few minutes. Once again they put whistle, get ready, go inside, like that. And exactly at 10 o'clock there will be a signal man who shows green signal in the starting of the point, and the drivers will go inside the engine and they will get ready. That is called initial velocity, that is 0. The train will be steady, stationary, and all the passengers will go inside, occupy the places. Some go to sleeper class, they will search for the seats and all. So all of it will be seated, and at exactly 10 o'clock the train starts moving, and there will be some fellows who come late and they will jump. Some of them will jump outside, some of them will go inside. All those things will happen, but dangerous, should not do that. But once train starts, you should not go inside like that. But due to some circumstances they do it. So starting initial velocity is 0, and after some time what happens, when the train leaves the station, it slowly picks up speed, is it not? So that picking up a speed, so velocity go on increasing, that is the change of velocity, that is what is called as acceleration. So until what? So after some time it goes with the uniform acceleration. The acceleration of an object during its motion is constant. Suppose it picks up a speed of say 80 kilometers. In broad gauge will go up to 80, 100 also. Now they have found a train which move with a speed of 180 and 200 kilometers also. Bullet trains and all you have heard about. So anyway, if it is constant, when it becomes constant, when there is no other obstacles for the train, no other signals, no other train passing by, and so on. So we say that the object is moving with uniform acceleration. Means what? The change in velocity will be same. There is no ups and downs. What happens when the next station comes? The station master will go on slowing down. Station master means the driver who is in the train slows down. So that what you got? You got negative acceleration, that is what is called as retardation. Retardation means the velocity go on decreasing. So the train which was moving at 60 km per hour, when it reaches the next station, go on decreasing velocity until it becomes 0. When the next station comes, it comes slowly and stops. Is it not? It will give a jerk at that time. So suppose the time reach the station is say 11 o'clock. So exactly 11 o'clock it will come and stop. And here what happens? There will be reduction in the speed. That is what is called as retardation. So here there is increase of velocity, there is a decrease of velocity, we call it as retardation. And if the velocity is constant, we have uniform acceleration. Here unit is meter per second square for both of them. How do you get meter square? Because this is meter per second here. So meter per second is the unit for velocity, and then per second. So you have meter per second square. per second per second. That is what is called as retardation. Okay. For example, you have one more graph here. Find the distance and displacement from the given velocity time graph in the given figure. So, one figure is given. You are asked to find out distance travelled and also displacement. As we just now discussed, distance travelled is a scalar quantity, displacement is a vector quantity, the shortest distance. Okay. So, note this figure, this velocity on y axis and time in the x axis, horizontal axis. For 1 centimeter is 5 seconds here, 5, 10, 15 etc. the time, and this is the velocity in meter per second. For 1 centimeter I have 10, 20 etc. Okay, and this is done on both sides because this is velocity decreases in this case. This is increase of velocity, this is decrease of velocity, and solution distance travelled is equal to area of triangle OAB plus area of triangle BCD. So, this is triangle OAB and this is called BCD. So, area, if you add these two, that gives the distance travelled. How to find area? This is a triangle, half of base into height. Here also half of base into height. This height is say 20 here and base will be 25. So, half into 25 into 20, and this is half into 10 into 20. Like that you have to do it. Half of 25 into 20, of 10 into 20, that will be 250 plus 100, that is 350 meters. That is the distance travelled. Displacement, here you have to subtract area of triangle OAB minus area of triangle BCD. You have half of 25 into 20 minus half of 10 into 20, that is 150 meters. That is the displacement, and this is the distance travelled. Okay. Now, home assignments. Describe the motion of an object shown in the figure. Let explain it, means how it is done and what is the nature of the movement, all that you have to explain. So, this is position time graph, you have to explain it. Okay. This is the first question. Second question, compare the velocity of two objects. There are two objects called A and B, and where motion is shown in the figure. It starts from, both of them start from O. This is the velocity of two objects. We have to compare the velocities. When will you say that a body is in uniform acceleration and non-uniform acceleration? That you have to tell it, homework. And one more problem here. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. You know, spaceship means what? Say rockets will usually carry what is called as satellites, and that satellites will coming down. You heard? Sometimes they will come in the form of spaceships also, and so they will send signals. The signal will be moving in the velocity of light, 3 into 10 to the power of 8 meter per second. So, it reaches the signal in 5 minutes. What was the distance of the spaceship from the ground? The signal travels at the speed of light, 3 into 10 to the power of 8 meter per second. Okay, you try this. Okay, that you have to use the formula what you have just now told. That is very important as far as the space science is concerned. So, prepare for this homework. Okay, come prepared next class. Thank you.